Now we introduce a new equation. This is called Clausius inequality. And what it does is to express second law of thermodynamics in a mathematical way. Second law of thermodynamics tells us the direction of a process. For example, heat transfer can only happen naturally from high temperature to low temperature. How do we express this statement in mathematics? Whole integral delta Q over T, temperature, over the boundary equal to negative sigma cycle, and it has to be less than or equal to 0. This equation is called Clausius inequality. Okay, let's start from delta Q first. Q we know is heat transfer. Delta Q is just a very small part of heat transfer. Delta Q is heat transfer at a part of the system boundary, a very small part of the system boundary during a portion of the cycle. It's just heat transfer at a very small length over the whole boundary. So you may ask, why do we not use derivative Q? Why do we have to use delta Q? In terms of mathematics, derivative Q is equivalent to delta Q. They're the same. So if you do not like this delta sign, just in your mind, change it to derivative. The reason why we do not use derivative is because derivative is reserved for properties. For example, temperature is a property, so we can write derivative T. However, heat transfer is not a property, so we do not write derivative Q, but delta Q. Okay, it's just a convention we follow. In terms of mathematics, derivative Q is equal to delta Q. They're the same thing. Okay, and the second thing is the whole integral. That is to integrate over all parts of the boundary. And then the subscript b means boundary in this equation. Okay, so now we're done with the left-hand side. Then the right-hand side in this equation is negative sigma cycle. What is sigma? Sigma cycle must be greater than or equal to 0. This is what Clausius inequality tells us, because negative sigma must be less than or equal to 0, so positive sigma must be greater than or equal to 0. You can think of sigma as getting older, the direction of your aging process. If your sigma cycle is equal to 0, that means what? You do not get older or you do not get younger. This is reversible. And if your sigma cycle is greater than 0, that means getting older. Getting older is irreversible, which is everything in this world. Everything in this world is irreversible. And what if your design gives you a sigma cycle which is less than 0? For example, getting younger. What does that mean? That means your design is wrong. It's impossible. So this is how we express second law of thermodynamics in terms of mathematical equations. And sigma has a name. Sigma is called entropy production, which we will talk more in next chapter. Right, but for now, let's just remember sigma as getting older. If sigma is equal to 0, that means you're not getting older. It is a reversible process. If sigma is greater than 0, that means you are getting older. So this is an irreversible process, which is the case for everything in this world. And if your sigma of your design is less than 0, that means getting younger. So your design is wrong. It's impossible because it violates second law.